Welcome to The Explainer. We're jumping right in today, cutting straight through the noise to unpack the concrete, pressing risks of artificial intelligence. We'll be doing this by breaking down the AI Field Guide's deep dive into global impacts. So let's start with the million-dollar question that literally hangs over the entire industry. What actually happens when this technology misfires? I mean, we hear endless sci-fi speculation, right? But we really need to ground ourselves in the facts.
We're looking past that whole hype cycle. Because as the field guide points out, AI risks aren't just some hypothetical, distant future scenarios. These are current realities actively affecting our privacy, our society, and yeah, even our physical planet right now.
To map this out, our agenda today covers 4 main areas. First, privacy in the AI era. Second, copyright and deepfake dilemmas. Third, AI's hidden environmental cost. And finally, future risks and mundane harms.
Moving right into Section 1, privacy in the AI era, specifically looking at your data and AI. Now, the vocabulary around privacy can feel incredibly dense, almost like a giant puzzle, but it is absolutely crucial to untangle. Chapter 32 of the guide specifically breaks down the hidden, under-the-hood mechanics of how these massive models interact with the most intimate details of our lives.
Okay, the crucial starting point here is PII, or personally identifiable information. Think names, addresses, or even your very specific behavioral patterns. Why does this matter to us? Well, because if a massive model memorizes your PII during its training phase, there's a risk it could accidentally regurgitate your private details to a total stranger asking a prompt halfway across the world. No way we want that, right?
So, to protect that data, the industry relies on 3 main technical defenses. First up is differential privacy, which basically adds mathematical noise so no single individual stands out. Second is federated learning, which trains the model locally. And third, private inference, which runs models on encrypted data. But keep in mind, there's no magic bullet here. Each of these forces a really difficult trade-off between accuracy, speed, and privacy.
Let's actually ground this with federated learning to see how it works in practice. Step 1, you train the model locally, right on your device. Step 2, you aggregate only the mathematical updates in the cloud, never the raw data itself. This is the exact brilliant mechanism your phone keyboard uses to learn your favorite slang, or, your embarrassing typos, without ever sending your actual text messages to a central server. Pretty neat, right? All right, on to Section 2, copyright and deepfake dilemmas, focusing on society and media. Zooming out a bit from individual data to broader media integrity, we immediately hit these fiercely debated legal battles. With major publishers actively suing AI companies, we have to look at the facts impartially here. The core legal question of whether training on copyrighted material constitutes fair use remains completely 100% unsolved in the courts today. And then on the other side of that media coin, deepfakes. They are definitely no longer exotic sci-fi concepts. They are cheap, highly accessible tools driving very real harms today. We're seeing a rapid, alarming rise in deep cloning scams targeting the elderly, highly sophisticated political disinformation, non-consensual imagery, and widespread financial fraud. This is happening now. So how on earth do we defend reality? Well, there are 2 main approaches. Watermarking, like Google's SynthID, tries to hide an invisible signal directly in the media. But bad actors can often figure out how to strip it out. Then there are provenance standards, like C2PA, which act more like a tamper-proof digital receipt detailing exactly how the media was made. It's definitely a stronger defense, but adoption is still pretty patchy. The ultimate takeaway for us? We literally can no longer assume any audio or video is authentic without this cryptographic metadata.
That brings us to Section 3, AI's hidden environmental cost and its physical impact.
It's so easy to think of AI as purely digital, just kind of floating up there in the cloud. But while it isn't the biggest tech polluter yet, general cloud computing still holds that crown. The field guide urgently warns that AI's physical environmental footprint is growing incredibly fast, draining vast amounts of power and water. Just consider this staggering number. A single AI query consumes 2 to 10 times more energy than a standard Google search. 2 to 10 times! Now multiply that by billions of daily queries across the globe, and the energy totals become absolutely monumental. To really understand this footprint, we've got to separate it into 2 distinct buckets. First is training. This is a massive one-time burst of emissions, literally comparable to flying hundreds of airplanes just to build the model in the first place. Then there's inference. While it's a smaller cost per query, it's a continuous, cumulatively larger drain. Why? Because it represents millions of users relying on the AI every single day, asking it questions over and over.
In finally, Section 4, Future Risks and Mundane Harms. The big picture. Looking at that big picture, one of the most fascinating systemic risks is what's called a model collapse. This is a degradation that happens when newer AI models train on the increasingly AI-generated text of older models. Think of it like making a photocopy of a photocopy of a photocopy. Eventually, those rare human nuances and quirky edge cases are totally lost, and the system just regurgitates a blurry, worsened version of itself. Then, of course, there's existential risk, or X-risk, the idea that advanced AI could cause permanent civilizational disaster. The cultural debate here is incredibly intense, but we can neutrally map out the two loudest extremes. On one side, the doomers fear extinction and believe slowing down development is the only rational path. Opposing them are the effective accelerationists, or EACs. They fear stagnation, arguing that slowing down is actually dangerous because it just cedes the future to less safety-conscious actors. However, the field guide stresses that we absolutely cannot let that flashy sci-fi debate distract us from what they call mundane harms. Now, these aren't hypothetical in the slightest. These are highly disruptive, systemic issues happening to real people right now. We're looking at massive labor displacement, the dangerous concentration of corporate power, degraded information environments absolutely flooded with AI spam, and even state weaponization. These demand our immediate attention. I want to leave you with this really powerful final thought from the guide, which I think cuts through the noise perfectly. It says, a useful stance. The same person can think X risk is real and think mundane harms deserve more attention right now and think the tech is on balance worth developing. It's a beautifully nuanced perspective that holds multiple truths at once. So I'll leave you with this. How will you balance your concern for the future with the realities of today? Thanks for joining me on this explainer, and keep learning.